All right, so you have been assigned to the Cooking Treatments on Vegetable Pigments lab. So this is a set of experiments looking at how different cooking procedures affect the vegetable pigments. And I'm going to walk you through this because we're doing this a bit differently this week. All right, so again, you're going to find this here. So this is Cooking Treatments on Vegetable Pigments. The learning objectives are to explain the conversion of chlorophyll pigments to pheophytins as a function of time, so cooking time and pH, to discuss the various cooking methods, so whether a lid is on or off our pan, how much water is in the pan, if we're using a pressure cooker or not, if we're using a microwave or not, and how that affects different vegetable pigments, and also to determine the use of a lid and various types of water on the pH and cooking medium, and also how adding an acid or a base affects the textures of vegetables and their pigments as well. So I'm just going to walk you through the procedure. So I want everybody to read the procedure here. So this is the protocol. So again, we're using broccoli, red cabbage, and cauliflower for these experiments, and your group will be assigned one of those because there's a lot of data to enter this week. But it's very helpful. I want everybody to be able to look at everything. And carrots are being done in another lab, so we're not going to be using carrots. So this was the procedure that was used. So all produce was washed really well. So we started with fresh produce, and everything was chopped into uniform pieces, and 50 grams samples were used for all of the different conditions. So 50 grams. And then the vegetable was cooked according to whatever variation that we're going to go through here below. So just hang on. So after the cooking treatment, which is the condition that we're going to go through, the vegetable was removed from the liquid, and the liquid was reserved because we did some things with the liquid. The vegetable was evaluated by itself, so on a white plate for color, texture, and all that other stuff. It was tasted, evaluated for flavor, it was evaluated for odor, and also overall acceptability. The cooking liquid was poured into a glass beaker, and once it had cooled, we tested the pH with a pH meter. Also, the color and clarity of that liquid was evaluated as well. And all the data was recorded. And I'll talk about the data in a minute. So here are the variations in order. So the first condition was the vegetable was cooked without water. We actually had to put a little bit of water just so it wouldn't stick or burn to the pan. So about 25 milliliters of water, but we call this essentially waterless. So 25 mils of just regular tap water, and then again the 50 grams of vegetable. 50 grams will be used in each condition. And it was cooked until it was tender. So the total time for cooking was recorded until the vegetable was tender. Next, all in about a 1 quart saucepan, the lid on the saucepan, and it was cooked for 5 minutes. The lid on, and it was cooked for 15 minutes. The lid off for 5 minutes. The lid off for 15 minutes. In number 6, cold water was used. So cold water was started. So in an uncovered saucepan, a cup of water was placed and 50 grams of that vegetable, and it was heated uncovered until it was boiled, and then it was boiled for 5 minutes. Okay. Number 7, distilled water was used in the same manner. Numbers 8 and 9, a pressure cooker was used for either 2 or 10 minutes respectively. Numbers 10 and 11, a microwave was used either uncovered or covered. Number 12, a steamer was used. So that's this kind of strainer looking thing that you put in a saucepan. The water is heated underneath the steamer, but water does not touch the vegetable, and it was cooked that way. In 13 and 14, baking soda was added. So 0.3 grams of baking soda was added, and the vegetable was cooked for 3 minutes or 20 minutes. In 15 and 16, 19 mils of vinegar was added, and it was cooked for either 3 minutes or 20 minutes. And in 17 and 18, milk was added, and it was cooked for either 3 minutes or 20 minutes. Okay. And then, of course, there's some critical thinking questions to help you with your lab report. Now, here's special instructions for you guys because this is very different. Okay, so these instructions are included in the lab data section for y'all. Okay, so here we go. Okay, so here's your instructions. So again, you've been assigned to one of the 3 cooking treatments on vegetable pigments. So you've been assigned to either the broccoli, the cauliflower, or the red cabbage. So there's going to be an individual tabs for each of these experiments on the Google Sheet for this week's lab. So in your data tab, you're going to enter the data from a one-pager. All right, so I've assigned you broccoli, cauliflower, red cabbage. You're going to use a one-pager that has all the data in it. And you're going to enter the data from the one-pager into your assigned sheet. Okay, so you're then, with the data that you enter, you're going to plot line charts to be able to examine the relationships between cooking time, so all those times that I just mentioned, either 2 minutes, 5 minutes, 3 minutes, 15 minutes. So the relationships between cooking time and acceptability, cooking time and flavor, cooking time and pH, cooking time and odor, etc. All right, so cooking time is going to be the x-axis in all of the charts you make. So you're going to make several charts out of the data from what you enter. Cooking time is going to be the x-axis. All right, so let me do a little demo here. And I had I had my marker. Hang on one second. Okay. So cooking time is going to be your x-axis. Okay, cooking time. And then your y-axis is going to be all of those other variables. Okay, this is going to be the y. So you're going to plot time along the bottom, and then all of your other variables are going to be the y. So you could look at the relationship between the 2 variables. So it could be like this, could be like that, could be flat, okay, depending on the variable that you're looking at. All right. So if you need to standardize the data for the descriptive data, so convert terms that may have been used in the one pager to a number, you could do that. So you're going to add a column to do that, but just enter the data as it was used in the one pager, then add a column. So your partner and your heading for whatever you're using and the scale of what you would be using if it wasn't numerized. And it's up to you and your partner to decide on a scale for the conversion of your own. So, for instance, odor, 0 odorless to 10 extreme odor or something like that, depending on, what the author of the one pager had used for their descriptive terms. All right. But you can't plot words. You need to be able to plot numbers. So everything has to be numerized. All right. So let's show you some examples here. Oops. Okay, so here's the one pager for broccoli, and you're going to use this. The broccoli people are going to use this one pager to complete your data chart. So you're going to extract all of the data from this chart into your tab for the broccoli experiment. So you're going to need to, use this data. So again, pH is a number. So again, pH is already numerized. The acceptability rating is already numerized. You're going to need to put into numbers texture, flavor, and odor. Okay. Cooking time, we know 3 minutes, 5 minutes, etc. So that can be entered as a number as well. So that's all of your x-axis. So the chart is there for you to enter your data, add as many columns as you want. But again, you need to add the original data and then add your own columns if needed. Okay. Here for the red cabbage people, this is their data. So they have a pH, their pHs are here. All right. And she color coded everything. They had a smiley face scale. So they used an acceptability of 0 to 100. So again, 0 to 20 in quartile. So 0 to 24 was not so great. 24 to 49, 50 to 74, okay. And then 75 to 100 was pretty good. So you might want to convert that to something else if you would like. They have their cooking times here. Their conditions are labeled there as well. Okay. And then here's a picture for the red cabbage people too, so that might help you as well. The cauliflower people, so this is their one pager. Here are all their conditions with their minutes. Flavor is a descriptive term. Here's their pH, their odor. I would assume from this, and I do assume from this, that if there's an X through it, that would mean no odor. So this is their, so crisps, this was either yes or no. So an X means yes, it was crisp. A tender, so yes or no. An X means yes, it was tender. An X means yes, it was mushy, and so on and so forth. They even had a standardized color that they put in there. So it looks like you would need to scale that. And then overall acceptability was 0 to 100. Okay. So that is how you're going to do your experiments this week. And I think this will be really good practice. A, looking at other people's one-pagers. B, practice extracting and entering data. Okay, so data has to be numbers. You can't plot words or letters. Practice graphing data as well. And also, this will really help you write or develop your own lab report this week. Okay. But if you have any questions, please post them to the forum, or you can email me directly. And I hope you guys have fun with this lab, because I had a lot of fun looking back at these experiments and seeing what really great work the students did last year.